We're going to continue chapter 11 with permutations. This is something brand new. You're going to need your calculator handy for this, so if you don't have it next to you, push pause and go get it now. Permutations help you count the number of possibilities, the number of ways you can do something. Here's the definition. Write this down. A permutation is an arrangement of objects in which order is important. For example, if you want to know how many ways to arrange 4 chairs, or how many ways to arrange the first 4 people in a line. In order to be successful, you're going to have to know what an n factorial is. For any positive number or any positive integer n, so n could represent any number, the product of the integers from 1 to n is called n factorial and is written n factorial. This exclamation mark is known as factorial in math. So let me give you an example of what an n factorial looks like. Let's say we want to know the first 4 people, or how many different ways to arrange 4 chairs. Let's do that. How many ways are there to arrange 4 chairs? So you would use a 4 factorial. 4 factorial means that the first chair, you have 4 possibilities. One of the chairs is being used. So the next chair you have 3 possibilities. Now 2 of the chairs are being used. So the third chair has 2 possibilities, and the fourth chair has 1 possibility. So you would multiply those together using the multiplication principle. So 4 times 3 is 12, times 2 is 24, times 1 is 24. So there are 4 different ways to arrange 4 chairs. Eventually, this is going to be really high and hard to do in your head, so you're going to need to know how to do it on your calculator. If you have my calculator, you would do it this way. I'm going to click 4, and then I do this probability button, PRB, and I have NPR, NCR, and then I have the exclamation mark, so I push exclamation mark and enter. If you have a different calculator than me, see if you can find it. If you can't, go to Google. Google the name of your calculator and put n factorial, and directions should show up how to do that. Let's just try another one. In your calculator, find 10 factorial. Push pause and try that now. So 10 factorial Okay, so I have 3,628,800. Try one more. Try 7 factorial. Push pause and try that now. Did you get 5,040? Awesome. Okay, so let's count permutations. We're going to do this in the form of a word problem. You have 5 posters to hang in your room. How many ways can you arrange the posters? This is what you should be thinking. Maybe you're going to line the 5 posters right in a row along your wall. So this is the first poster, this is the second poster, this is the third poster, 4th poster, and 5th poster. The first poster has 5 possibilities. Okay, now 1 is hanging in that spot. So the next poster you can choose from 4 possibilities. Okay, now there's a poster here and a poster here, so you have 3 possibilities, and then 2 possibilities, and then 1 possibility. This is what you're thinking in the back of your head, but you don't have to write this out. If you are using all of your possibilities, you can use a factorial. So this is the same as this. And then solve. 5 factorial. There are 120 different possible arrangements of those 5 posters. So I would like you to try this next problem. You have 4, no, we did that one already. You have 3 posters to hang in your room. How many ways can you arrange the posters? Okay, so instead of writing it out like this is what you're thinking in your head. Instead, you're going to use a factorial. There are 3 posters, so I'm going to use 3 factorial to get 6. There are 6 different arrangements. Okay, but we didn't cover all the different types of permutations. In these last 2 problems, you used all of the posters. So here you had 5 posters and you hung all 5 posters up. Here you had 3 posters and you hung all 3 posters up. That's not always going to be the scenario. Sometimes you're going to have 5 posters and you only want to hang up 2, and you want to know all the different possibilities to hang up those 2 posters. So we're going to show that next. In order to do that, you have to know about the permutation button on your calculator, or how to express it in math. So we're going to use something that looks like this. This is a lowercase n, uppercase p, lowercase r. P stands for permutation. N stands for number, or the number to start with, or the number of total possibilities. And R is how many numbers to multiply, or how many you're using. So for example, if we were using this first problem right here, this poster problem, I have 5 posters and I want to hang all 5 up. I would put a 5 here. P stays because it's a permutation. I'd put a 5 here because there's a total of 5 posters and we're using all 5. Then I could calculate it on my calculator. But as I mentioned before, that's not always the scenario. Let's say we have 7 posters and we only want to hang up 4. So let's visualize this first. We have 4 posters that are going to be hung up on the wall. So 1, 2, 3, 4. The first poster, I have 7 options to choose from. The second poster, I have 6 options to choose from. The third poster, I have 5 options, and the fourth poster, I have 4 options. I cannot use a factorial here because I'm not multiplying all the way through. There's not a 3, 2, and 1. So I'm not going to use the exclamation mark. Instead, I'm going to use this notation. So I could multiply my calculator 7 times 6 times 5 times 4, enter, or I could use this. It would look like this. There are 7 total posters and we're using 4. And then I would go on my calculator, and instead of doing 7 times 6 times 5 times 4, I would use the permutation button. So I'm going to, on my calculator, I'm going to push 7 first, and then this probability, NPR, and then I'm going to click the last number, 4, and enter. Again, if you have a different calculator than me, go to Google and ask how to enter permutations into your type of calculator. Okay, I want you to try. Let's say you have 6 posters and you only want to hang up 2. Try that now. So again, I could write it out visually. I could draw 2 lines and do 6 times 5, or I could write a permutation. There are 6 total posters and we want to use 2. So 6 permutation, 2, enter, is 30. There are 30 different ways to hang up those 2 posters.